Let's go into that. Okay, so our first schedule, as you can see on here, we intended to cover cloud computing on the 30th of July, along with a few other things that had to continue. So again, the updated schedule looks something more or less like this. Now we're going to try to round everything up by the end of the year. Okay, so today it's going to be 5 p.m. in Cameroon. The next 2 days, it's still going to be 5 p.m. in Cameroon. That will be October 29th and November 5th. But on the 6th of November, there is going to be a clock change here. So our time is going to fall backwards by 1 hour. So I'm going to maintain the 12 o'clock time here, but it's going to be 4 p.m. Cameroon time because Cameroon doesn't move their clock backwards. So that's why there's a difference in the time. So we're going to start at 4 o'clock. Will that work for everybody, or do you want me to maintain the 5 p.m.?
It's going to be okay.
Yep. Sounds good. If it's going to be okay, we can do
think,
that. Yes,
I
Beatrice.
think the 4 o'clock is too early for me, a little bit early.
Okay, then
But
we'll
I
try
could
to walk
catch up.
around. Yes, we'll try to walk around that then and see. I can always shift my time to 1 p.m. and then it will be 5 p.m. your time. Since we are already used to 5 p.m., I can be flexible, that's fine. Instead of having
Right.
everybody change their time, just one person.
Those in the West, there will be no change.
Yes, you guys will have no change in your clock, but I'm going to change my clock. So I'll just have to change it. And I'll have just 1 more hour to prepare ahead of time so that we can address this. Sounds good?
Those in Cameroon, their time will be adjusted to our time.
Very good.
I see. Okay. All right. So again, a quick overview of what we covered. We started off with introduction, right? Introducing the series altogether. Talked about a few things in the history of computer science, right? And we also talked about the differences between IT, computer science, and information systems. We talked about some of the history of the 5 main players in this industry: Facebook, Amazon, Microsoft, Google, and Apple. And the following week, we went ahead and talked about career paths. Okay, the 10 major areas in technology field that you can get interested in. And from then, after talking about not just the career path, but also the learning paths, being able to learn the fundamentals, getting knowledge, how you get it, where you get it from, and then building on your skills, as well as innovating on top of that, depending on which branch that you want to pursue in IT. If you want to go into the technical branch, staying everything technical, or if you want to get into, say, financial or, fintech and so on and so forth, or if you want to get into leadership role and, being a boss per se, the routes that you had to take. Following that, we talked about hardware, software, the main components in computer, hardware, the things we can touch, software, what actually gets a computer doing all the things that we needed to do, the different types of software, operating system, applications, and so on. We also talked about the internet and the web, how websites are built, what it's all about, how the website evolved from, being just static, boring pages to it being what it is right now. The trend that it had to take, dealing with the browsers, also having to deal with different devices, tablets and mobile devices or cell phones. We talked about cybersecurity, just the fundamentals, obviously, not the entire picture. And also concluded with databases, talking about what they're used for, how we leverage them in all the information that we gather. So today we're going to dive into cloud computing. That said, a few things we'll talk about. We're going to get an introduction to cloud. But in order for us to really understand, the best, to get the best out of this, we have to talk a little bit about network fundamentals. I know we talked about hardware and software. We might have touched a few things here in the network, but we're going to talk about that and then carry on with the most things that we need to talk about in cloud. My goal today, let me go back to that. My goal today is to try to get everything done in 1 hour, okay? But also give you enough time to ask questions. So obviously we're going to see if I can squeeze in network fundamentals in 15 minutes. I don't know if that's possible. Might go over that. And then we'll talk about cloud principles for about half an hour and talk about cloud storage, cloud design, and the big players in the cloud computing. Sounds good?
Yes.
Awesome, awesome. And that's some of the synopsis so far. All right, so let's, oops, that's not where I want to go to. No, that's the old one. All right, so that said, what questions do we have? No questions?
Please, something worries me.
Go for it, go for it.
Yes, I wanted to ask, is a cloud an imaginary software or meaning a hardware?
Very good question. What exactly is a cloud? Can anybody answer that question?
Before asking the question, I thought I had an idea about what was a cloud.
Okay, go for it. Tell me, what do you think a cloud is?
I think a cloud is an imaginary application that is mainly used to store information inside.
There you go, there you go. So you have an idea of what a cloud is, right? It's virtual. I know you use the word imaginary, it's virtual. So more or less, a cloud then is, in other words, instead of me storing all my information, all my pictures, all my
And actually,
data.
I think it's a storage in space.
Exactly, in space. But instead of me storing all my data on my computer, I'm storing it on somebody else's computer. And as long as I have a connection to that person's computer, I can have access to that information. So it frees up my computer, but that's just one piece of the cloud. The cloud is not just about the space part, it's also about a lot of different things. You can also store your applications. Instead of you having, let's say if you're using Microsoft Word, instead of me using a CD to install Microsoft Word on my machine, or using a file that I downloaded on the internet to install it on my machine, I have it installed on somebody else's machine and I'm just using it. So all I have to do is use a web browser. Everybody remembers what a web browser is, right? So a web browser, for example, you have Internet Explorer, which is now obsolete. You have Google Chrome, you have Safari, you have Mozilla Firefox. Those are all web browsers. So web browsers are those tools, those software that we use to be able to get to a website per se. So with that, you can easily access another person's machine. Okay, does that make sense?
Yes, it does.
Yes.
Awesome. So again, cloud concepts. I really didn't want to start here, but oopsie, I think I might have to uninstall this. Open with, all right. So cloud concepts, again, in a nutshell, I might have to go through my, I know you guys cannot see this for now, but I'll have to do it that way. Okay, it's on upload and everything, that's good, awesome. All right, that's being extracted. I can go ahead and tell you. So cloud concepts, again, let's take a scenario, for instance, where I've decided I want to start a company, right? I want to start a business, or I want to open an office. In order for me to open an office, I'll need, obviously, each one of my employees to have a computer, right? I'll also need to build a network. I'll need a server and so on. Does everybody remember what a server is? Anybody? Yes, no?
Yes, I think I have an idea of what was a server.
Okay, tell me, please.
I think a server is mainly hardware that is made that many provide services to clients' computer, which are requesting for information for services from the server.
Exactly correct. So again, think about our computers are all connected, right? One way or another. If you're in a company with 10 people, 20 people, 100 people, all the information that you need is saved on a server. The server is like what you have in a restaurant. The kitchen will be the server where all the food is being kept. When you come in, you request your food to be made. They'll get food from the kitchen and make your food, and you are the client. So the client requests for resources from the server provides the resources to the client. So in this case, cloud network or cloud computing has to do with you saving all your resources on somebody else's space, saving it out there and using internet connection to be able to utilize it. So that's why it's usually denoted. Let's see. Okay, now I think I should have, oh, I don't have it yet. Let me add it on here. So it's usually denoted by a cloud. The cloud signifies the internet, right? Because the internet connection, it's in the cloud per se. So when you have all your information, or all your services being stored in the cloud somewhere, then it's noted of, should I say, let me go ahead and do it this way. Then it's actually seen as a cloud computing. Does that make sense?
Yes, yes.
Yes, it does. But I have a question.
Go for it.
How long has the cloud computing been existing? Because I've not really heard about it though.
Very good question. So let me
Something.
go now to actually talking about how it all began. Okay. So I'm going to share another screen to you guys because I think the screen I'm trying to share is being very problematic. Let's see. All right. So this would be a better option. So let's go back all the way and start with cloud services. All right. There are a few services that let's see. Let me open this. All right, let's share this one more time. Hopefully this works. Okay. All right, can you see my screen now?
Not yet. It's still sharing.
Okay, that's weird. How about now?
It's okay now.
Okay, so you can see, for instance, these are some examples of cloud services that we have, right? So what do I mean by cloud services? These are providers. These are people that have dedicated machines, right? Dedicated servers for us to be able to utilize those servers and do what we need to do rather than having it on our machine. For instance, Netflix has a server that all those movies that are being watched are stored on there. If you need to watch a movie, you click on the movie, it pulls it from the YouTube Netflix server and streams it on your device, right? Similar to Gmail, right? Gmail has all your emails saved somewhere, right? When you need access to that email, it gives you the access, okay? Does that make sense? Everybody with me?
Yes, it does.
Now, but how did all of this work before, right? Before, everybody has a computer, right? You have your desktop. In your desktop, you have hardware, you have operating system and applications that make up the software, just like we discussed from the start, right? Now, once you start having a company, an office, multiple people having to use the same system, the same software, the same devices, the same data, then you create a server. A server, then you think about it like being a back room, maybe a closet. You put all your stuff in there. Now, each of these people or employees can actually connect to that server and you use it, okay? Traditionally, that's how things were done. You have a big computer somewhere in the back office that everybody's stuff is stored in there, and then you have wires connecting to them. But then it becomes very difficult to do things that way. Now, the next thing you have to think about is cloud computing comes in to be able to provide you these services. You don't have hardware anymore in a closet. You don't have a bunch of servers because you have to first have the money to buy these servers and save them in there. And there are many different types of servers. You might have a server just for your website. That will be called a web server. You can have a server just to store all your files. That will be called a file server. You can have a server just to store all your databases. That will be a database server. You can also have a server to store all your software, all your applications, every software that you use in your company or that you use personally. That will become an application server. You can have a server just for your emails. That's an email server. There's so many different servers, right? Instead of you buying each and every one of these hardware to customize it or configure it to work as you need it to, you have somebody that is actually doing all of this for you. It becomes flexible because if now you have more people coming to your website, you created a website today, there's just 5, 10, 20, 30 people that are going to it. Tomorrow your business booms, you need to improve that server. Maybe you bought a server for 30 gigabytes, but now you actually need just 1 gigabyte. You're wasting all that space, wasting all that money. So it becomes flexible and scalable, okay? You don't have to worry about installing, upgrading every new time, and so on and so forth. All of that is managed by the provider. So you have access to the latest technologies because they're also managing servers for other important clients as well. So you have enterprise level protection that goes with it. And you don't have to worry about cost for paying someone to be doing all these services for you because you have to hire an IT staff. You have to make sure you take care of the administrative costs and so on. So those are all reasons that you would want to do cloud computing. Now, before we went into that, one intermediate that I need to remind you is before you move from the traditional to cloud, there was something known as virtual machines. A virtual machine then would be, you have maybe your computer, your laptop, or that server, and you want to create multiple machines in the same server. So for instance, now I'm using a Mac operating system. I can go ahead and install what is known as a hypervisor. This hypervisor allows multiple operating systems to share the same hardware. So they are going to share the same CPU, the same hard drive, and so on and so forth. So those resources are managed. When people learn Linux, which is one of the operating systems, they learn how to install a hypervisor or how to install a virtual machine on Linux. The virtual machine they usually install is Windows because Windows is very popular so that they can run Windows and run Linux side by side. It's the same thing on a server. When you buy one major server, let's say your server you bought is Linux, you decide to install a virtual machine on it. That virtual machine, you can configure it to use maybe 5 gigabytes, 20 gigabytes, 30 gigabytes, depending on your demand, right? But then that only allows for a one-to-one relationship, between, it doesn't allow for one-to-one relationship, but your resources are still limited. It doesn't have that elasticity. Once you get up to that 5 gigabyte, that was your limit, then it's exhausted. You have to create a new one. Okay. So that's where that's where cloud computing comes into use. Okay. So again, If you're looking at building a data center, what are some of the things you're going to need? You're definitely going to need, say, a DNS server, a web server, a file server, a firewall server, and so on and so forth, right? If you go ahead now and say, okay, you have established your business in, in one location, let's say you established it in Limbe, and you realize that it's booming, it's good business. You need to go do the same thing in Bamenda. You have to do this over and over. And again, you're not sure. Are you utilizing all of these systems? Are you, wasting the resources, or are you running out of resources in some cases and so on? That's a lot of configuration power work that you have to do, okay? Now, if you talk about a virtual server, like I explained earlier, right? You have a hypervisor that sits on your CPU, your memory card, your hard drive, and so on. Those physical resources that you have, you're able to create multiple machines on top of them. But that did not do the work, because eventually you run out of resources. You still have upfront costs. You need space to be able to save all those servers. You need electricity, utility costs, and so on and so forth. Now, at the end of the day, the definition of cloud computing, it enables you to consume compute resources, such as all of that, just like electricity, rather than having to build your own and maintain it, okay? So it is more like pay as you go. Does that make sense now?
Yeah.
So again, it's not something that has always happened in the past. In the past, things will always happen separately. You need to have your servers in your server room and so on. But that has made it easier for you. Imagine if I sit today and I say, I want to open a business in Yaoundé. I want to open a business in Paris. All I have to do is contact one of those major cloud providers, Amazon, Google, Microsoft, whichever of them I'm interested in. Once I go in, all I need is my login, right? I log in, I request, I need this number of cloud computing resources. They use my email, sign in, sign out, use my credit card, and they tell me, what kind of server do you need? I need a database server. They give me one, I configure it, and I launch it. That's good. I need a web server. I can create one as well, just like that. But in the past, I'll have to go somewhere and buy the hardware. I'll have to go and buy that machine. Make sure that the CPU, the RAM, all of that is up to standard with what I need. If it's not enough, I have to go back and buy it. Just buying it is not enough. I have to also sit down and configure it. If I don't know how to do it, I have to pay someone to configure it for me. If something goes wrong, I have to call that person, pay them again to come and do maintenance and so on. So at the end of the day now, what you do is you're able to have all these servers being provided to you by a cloud provider. You're not the only one on that server. You have many people using that server. Banks are using it. Hospitals are using it. Schools are using it. Government institutions are all using those servers. You're saving your information on Google Drive and so on. Other companies are also saving their information there. Your information could be sitting right next to someone else's information on a server, which means they have already paid for all that resources. You're all paying for it and sharing it, okay? Does that make sense? Everybody good with that, right?
Yes.
All right, so that's just a quick introduction of what it actually means to be to have cloud computing or cloud services. Now, there are different types of cloud services, which I don't want to go into that yet. I'll prefer that we talk a little bit about networks, okay? So I'll tell you a little bit. Yes, go for it.
Please, I've not well understand about the different data centers. I'm not well understand that part.
Okay, good. So data centers, we'll definitely come back to that, okay? Because I want to be able to explain to you first what a network is. And then when we talk about, let me go back to Oops, I think I should just share my entire screen. That's what I should do. That way you can see what I'm doing here. Okay, new share. Desktop. Okay, you can see my screen, right?
Yes, yes, I can.
Yes.
Okay, so like I said, my goal was to try and do a quick introduction and then talk about networks. But data centers, we're going to talk about data centers when we talk about storage. Does that make sense?
Yes.
Yeah, so when we talk about cloud storage, I'll talk more about data centers, okay? So let me go ahead and say, put that in there for now. But in a nutshell, a data center is a location where all your servers are being saved. Okay, so if I have I need a lot of servers saved somewhere, I'll go ahead and buy 100, 1,000 of them if I'm Amazon or Google, and go and save it somewhere. So that becomes a data center. Does that make sense?
Yes, it does. Yes, yes, yes.
Okay, so for instance, in the past, let's say I am, my company's name is ABC Company. The ABC Company is located in New York. I'm going to buy a bunch of servers and then keep them in New York. That will be my data center. That's where all the data is being stored. And then I decide that I want to have another company in Cairo in Egypt. I'll have to buy a bunch of servers again and go and save them in Egypt, in Cairo. And then that will be another data center in Cairo, Egypt. Does that make sense?
Yes, yes.
Okay, awesome. So in order for us to better understand this, let's go back into cloud fundamentals. Okay, so with cloud fundamentals, I'm going to talk about a few things. Protocols. Do we remember what protocols are?
Yes, I think I can remember what was the protocol.
Okay, awesome. Let me know. Can you tell us what is a protocol?
I think a protocol is mainly a set of instructions that are mainly used by user to run over the internet, something like that.
That is very, very good. Does anybody have anything else to add? I really like that. Are you reading it from your notes from the last class?
No, I'm not reading it. I just remember.
Okay, that's very good. Yeah, protocol, just like a president has protocols, just like every company, every organization has protocols. Protocol is just a set of rules, okay? There's a protocol for you to cook rice. You're going to need a pot, you're going to need fire, you're going to need, salt, water, the rice itself, and so on. So all of those things make up a protocol, right? So again, in computer science, in networks, you have protocols. So let me go into detail what we mean by this. So let's talk about network concepts. So a network, what is a network? Okay, a network is pretty much what you get when two or more devices communicate with each other. When it becomes a million devices like the devices that we have in this world today, then it becomes a more complex network, right? So you have a cell phone, you have a computer, they are all connected to your internet, or they are all connected together, that makes up a network. At home, you might have a network. All the computers connected in Douala make up a network. All the computers connected in the world make up the internet, okay? In order for that to happen, each device will have a network adapter. So every device, be it your cell phone, your TV, if it's connecting to the internet, all those devices have network adapters, okay? You also need a transmission method, and you need a protocol that we set. The protocol, again, the set of rules that need to be in place for it to happen. Now, there are many protocols, the way things started from way back when in history, okay? A lot has changed. All those protocols that have changed, what we actually have today is known as TCP/IP, which is Transmission Control Protocol, Internet Protocol. Is the protocol that you use for the internet, okay? So again, it's just a set of rules that help us to be able to transmit information from one place to the other. So what are some of the things that we need? This is very technical for now. If you think about your computer, if you need to send an email, you need to first of all interact with a web browser. The web browser needs to take you to a website, and then you type your email. Your email has to go from that application, goes to your machine's network, and then goes to the cable or the wireless internet to get to its destination. So there are many different things that have to take place, okay? All of those need different protocols to get it done. I don't want to go into that in detail, but we can talk about that another day. So all in all, what it's telling you is each of those, again, we talked about internet. We use IP, right? Internet protocol. The internet protocol relies a lot on your IP address, which is internet protocol address. It's like your home address. If somebody has to send you a letter, they have to write your address on that letter. So we also need that IP address to be able to send information across the internet, okay? So speaking of which, once that is being sent, it goes to the particular location. Within that location, within your server has certain doors, just like an apartment complex. An apartment complex has one address, but each door has its own number. So if you're sending information that has to go to an email, it has to go to a particular door. That door is known as a port. So the network has internet protocol address, which is the IP address, and the IP address goes to a particular port, okay? So depending on the protocol, and there are many different protocols, there are different types. You can have HTTP, which is Hypertext Transfer Protocol, is what we use for the internet. If you're trying to get to a website, it's going to go to a particular port. If you're trying to get remote desktop protocol, if you're trying to connect to another computer remotely, this case might be you're trying to connect to another server, then it has a different port. If you're trying to do SSH, which is secure shell, then you're trying to connect to a different port or door. The same with VPN and so on. So the next slide actually shows you the different ports that it connects to. So each network has to go to that port. If you're trying to connect to the internet and you don't go to port 80, you're not going to get to a website. If you need a website to be very secure, then you have to go through port 443. So those are all different examples. It's the same concept that you also have on the cloud. The only difference is the machine is not physically located in your company or your office. It's located somewhere that as a data center, okay? So that's an example. And again, the difference between HTTP and HTTPS is that HTTPS is secure. So if you're going to go to a website that you have to enter your credit card number, your date of birth, all those sensitive information, then you need to make sure it's HTTPS, okay? So again, why do we use virtual servers? It helps us to get extra capacity. Okay, we can also use it to have different environments and also for testing different platforms, okay? So let's talk a little bit about RDP. RDP is a protocol that you use to log onto an online Windows server, okay? Some Windows machines usually come with it. Others need other clients need different software for their system. So in order for you to use RDP, you need public and private key. We're not going to talk about that here because it's going to get us in depth. But another thing I want to talk about, as I said, we're going to talk about protocols, HTTP, RDP. We've talked about this so far. SSH is again just secure shell. A shell, what exactly is a shell? When we talked about hardware or we talked about computers, we have hardware and software, right?
Yes.
The hardware connects to the software using a kernel, okay? So think about a palm nut, right? In a palm nut, you have the kernel inside and then you have the shell outside. So the kernel is what connects you to between the software and the hardware, but the kernel itself connects to the shell. So if you want to write software to get to the hardware, then you want to go through the shell. Does that make sense?
No, I don't understand.
Okay, so when you have a hardware, the main hardware on a computer, you have a screen, you have a keyboard, you have the internal hardware, just like the CPU, the memory card, the hard drive. All of those get instructions to send to your screen or get instructions from your keyboard. In order for you to send instructions from your software to your hardware, it has to go through the kernel. The kernel is a part of, let me go ahead and see if I can get a quick visual here. Operating systems, kernel.
Like a transmitter from hard to soft.
Yes, exactly. So again, I think we talked about this briefly. So if you look at the schematic, okay, of what you have on your device. So you have a hardware is the main thing that we want to get to. We want to send our instructions to the hardware. We want to send our instructions to the CPU so that the CPU can actually get things done for us, okay? In order for us to get to the CPU, we need to go through the kernel layer. Around the kernel layer, you have the shell. So the shell in every operating system, you have to connect to the shell to get to the kernel, be it Windows operating system, Mac operating system, Linux operating system, okay? And then your application now is out here. Your application again is the software. Software and application are usually interchangeable, okay? Here's another representation that could be helpful. You have your CPU, your memory, and your devices, which are all hardware. It connects to the kernel and your applications talk to it. Does that help?
Yeah.
Okay, awesome, good question. So in, oops, where was I? Yep, I was going to jump ahead, but I think we had to clarify that. So yes, we've talked about what the kernel is. So a kernel, again, is what they usually say if you want root access. If you want to have root access to your cell phone, for instance, then you have to get access to the kernel. In order for you to get access to the kernel, you need a shell, okay? So the shell is what is being used here to access your web server or your email server or your database server. Does that make sense?
Yes, it makes sense.
Yes, sir.
Okay, so again, that's part of the network, but how does the network work? Okay, if we want to connect to the network, we usually will have to use just a regular, let's say, how can I put it? Here, let me give a schematic, right? This is what the public internet will look like. You have all your data that's residing on your data center or your server, right? Now you have different devices that are trying to get to that server. You use the internet to be able to connect to it, okay? You could be using it through Bluetooth, you could be using a wired connection, or you could be using other different destinations to connect to it. That's how you connect using the internet to your data or your server. That is what a public network is. In order for you to make sure that it's secure, you use VPN. I know most of you must have heard about VPN, right? Like, hey, I'm going to use VPN to be able to connect to YouTube if they are going to block it.
Yes, like we in China, without VPN, I cannot use even WhatsApp, not to talk of Facebook and the others. Anything from Google, you need VPN.
So that's an example of what a network is. What exactly is VPN? VPN is a secure or private network connection that occurs through public network. So instead of you connecting to the internet this way and everybody can see where you're going to, what you're doing, you use VPN. What does VPN do? VPN actually gives you a tunnel. So think about a car that's driving through a tunnel. Before the car gets into the tunnel, you know what the car is made up of. Once the car is in the tunnel, you have no idea what it's transmitting. So in this case, you have your computer or your laptop, you're sending email or sending data, whichever form of data, a message or trying to go to a website, you go through the tunnel and you get to the server. Most of this was done because of companies. Say an employee in a company is traveling somewhere. You know, I'm in the US, I'm traveling to Cameroon, I'm in Cameroon, I need to work from Cameroon. Then in order for me to send an email, I cannot just send it over the internet. I have to download VPN, use the VPN to connect directly with my work. And then the information I'm sending goes through the tunnel and nobody can sniff it or try to get it, okay? So that's an example of what VPN is. Does that make sense?
Yeah.
So with
Please,
VPN
please,
architecture, you get your message gets encrypted as well. So the encryption usually needs two things. So it's like having a box, you have sealed the box and somebody needs a combination to be able to open that box and get the information in there. So you have a private key and public key. I said I wasn't going to talk about this because it's a little bit more technical, but I just want to introduce you to networks per se, okay? So like I said, we've talked about the different protocols that we need to talk about. There are different ports. So let's see, we've talked about VPN and we've also talked about the different
please, I
HTTP.
have a question.
Yes, go for it.
Is this means that the VPN is mainly used to ensure the integrity in the CIA, something like that, that we did in the
Excellent.
previous.
Excellent work. It's good that you're actually putting this together because when we talked about cybersecurity, we talked about CIA being the most important part. C standing for confidentiality, to make sure nobody sees your information. I for integrity, nobody changes it. It's the same thing that you're sending, it's going to arrive, and A for availability. So yes, when you use VPN, you're actually making sure that your data stays the same. The integrity of the data stays the same. If you're trying to use VPN to connect to your bank, for instance, I want to withdraw $100 and then withdrawing that $100, or I want to transfer $100 from this account to that account, then it works perfectly fine. Nobody is going to change it and say, transfer 1 million from this account to some other account, okay? That's integrity. Now for confidentiality, we also use VPN for confidentiality because you want only the bank to know your transaction. You don't want anybody else to know your transaction. If you're sending an email, if I'm sending an email to John, I only want John to be able to read that email. I don't want Mary to be able to read that email. If I'm sending an email to Mary, I don't want it to be read or intercepted by John. So with VPN, you're able to achieve those two. It doesn't really bother about availability, just those two, integrity and confidentiality. Does that help out?
Yes, yes.
Awesome, awesome.
Yes.
The next thing,
Thank you for that.
you're welcome, you're welcome. The next thing I wanted to talk about is load balancing. I don't think I have it in here, but let me double check and make sure that it's in there. We'll talk about firewalls later on. But load balancing again has to do with, we talked about that already. And I'm not going to talk about routers. And I talked about that too. And that. So load balancing has to do with the fact that now that you have all these servers, right? Let me go back to the different servers you can have. You can have a web server, you can have an email server, you can have a database server, you can have an application server, and so on and so forth, maybe even a file server. Now, all these servers belong to your company, but your company has only one IP address that you're going to make to the public. So if the public wants to connect to your company, they'll connect to this IP address. Based on what they are requesting, you're going to have one server that is the outside facing server. That server is going to receive all your requests and it's going to act as a load balancer. What does it mean by a load balancer? You have one server sitting here, and in this case, you have 5 servers. Based on your request that comes in, the request wants to, somebody wants to check your web page. Okay, you send them to this server. You know, somebody wants to send an email, you send to this server. If this server is too busy, you send to another one. So it actually balances the load so that your server does not get too crowded. It does not get too congested that it cannot do its job. Okay. So if somebody is trying to hit your server with denial of service, you can actually branch it. So this is just an example. Maybe you have 3 web servers, or maybe you have a capacity of 3 or 4 in here, and 5 and 3 and 4 and so on. Then you can manage it. If you're trying to access a file, everybody wants to get to a particular file. Then 2 of the servers are very busy. You route them to the other 2 servers. So that is what exactly a load balancer is. Okay. So that's one thing I wanted to point out, what load balancing is. On the cloud computing, this is very big because everybody might be trying to get access to that cloud, to that system. So they are able to have that built into their system to be able to help you to balance the load, and you're not going to have issues with it. Okay. Now, finally, let's talk about domain name system. Do we remember what domain name system is?
A domain name system.
We talked about this when we talked about internet and web. Domain name system is just like a table. If I want to go to a website, let's say I want to go to yahoo.com. It's easier for me to remember yahoo.com, but this yahoo.com actually matches a particular IP address. So the job of the DNS is to make sure that yahoo.com matches a particular IP address. Once I go in and I type in yahoo.com, what the DNS does is that the DNS looks up a table. It has a lookup table. On that table, it has URL, which is Unified Resource Locator, and it has IP address. Because the human being is very, it's not very good with memory. I cannot remember what the IP address is. Maybe it's 168.122.34.7. I'm never going to remember if that's the email address of yahoo.com, because I also have to remember the one for Gmail. I have to remember the one for CNN. I have to remember the one for BBC, and so on and so forth. But it's easier for me to remember these URLs. Now I'm going to depend on my DNS, which is domain name service, to be able to say, hey, this guy went in and typed this URL, take him to this IP address. Does that make sense?
Yes, yes.
Yeah, so that's what the domain name system does. It takes a URL, converts it to its corresponding IP address, and takes you to that website so that you can use it. The firewall is a whole different story. The firewall, again, as we know, is just there to filter content. So again, the name came from, having houses that are side by side next to each other. If one house is on fire, it can easily transfer to the other house. So building a wall in between 2 wooden houses, for instance, will prevent the fire from, transferring from one house to the other house. Okay. So the main thing it does is you set a bunch of rules. Okay. So if you set a rule and say, okay, if this person is trying to go to this URL, let them go to. If the person is trying to go to a certain URL that is not on our list of URLs, it's not going to go to. So if somebody is trying to get to a machine, if somebody is trying to get to the IP address of our database, we're going to block them. If we have a firewall in here that's telling us that do not allow access to this database, do not allow access to this file, and so on and so forth. So that's exactly what it is. Now, I know we really went over time on that one, but let me run through it real quickly so that we don't miss anything. So what is a network? A network is just connection of 2 or more devices, right? The devices definitely need network adapter, they need a protocol and a transmission method. We've talked about protocols, TCP IP being the internet protocol, and HTTP being the protocol that is used for websites, okay? So there are many different protocols out there, which we talked about. RDP is another example for remote desktop. SSH is for secure shell, VPN is for virtual private network, and so on and so forth. Each of those protocols have a network port that if you need to connect to that device, you have to point not just the IP address, you also have to specify the port to be able to make sure your transmission is successful, okay? HTTPS is a secure HTTP network or secure HTTP protocol that is used when you have, say, sensitive information that you have to transfer, okay? And why we need virtual servers, we need it for improved capacity, end-to-end testing, and also for staging stuff. So we talked about RDP being a protocol that you use to connect to a server, you know, Windows Server, for instance, and the different types of clients that it uses. A firewall, it filters network traffic based on rules that you have defined. You, the administrator, would say, let this traffic go, don't let that traffic go. It also helps to block malware. You know, malware, again, we talked about that in cybersecurity, malicious software. Okay, so it checks, you know, it might check and say, hey, this particular software, we know this signature, this one is going to cause us havoc. Don't let it work, don't let it go into our network. Because when you look at the different types of firewalls, again, you have one that protects your network, and then you have one that protects your computer. So the network-based firewall will protect the entire network, every device that's on the network. But for your host, when you have a firewall on your particular host or client machine, a single computer, then it's based on a software. So again, think about your network. You have public network, what's outside in the public, and you have private network, what's in your particular company. You have a demilitarized zone, the part that's between those two networks, where, you know, everything is free, you know, it's not really affected. Next up, again, when it talks about firewalls, a default for firewall is that it's going to deny you entry. If it doesn't have, if you're not explicitly put in the rules saying that go through, it's going to block you. So if you set up firewalls for a company, no information is going to be going out, except you start including, say, hey, if somebody is sending information through this port, let it go through, and then one will go through. If somebody is sending information through that port, let it go through. Otherwise, if all your ports are open, then everybody can attack your company. So ACL is also your list of access control list. You know, it's actually telling you, hey, allow this access to go through, allow that access to go through. Is it inbound traffic or is it outbound traffic? So they are all different, okay? DNS, we talked about DNS. The main purpose is just matching your IP address and your URL. And then how it works, okay, it takes the information from your host, pairs it with what is on the DNS table, and then checks if it's there, it fulfills the request, and that's that. Load balancing, again, that was before we ever had cloud computing. Okay, it helps you to be able to balance your request so that one server does not die. You know, before, when you have, say you have 4 servers, when the request comes, you go to 1, 2, 3, 4. But now it depends. If this one has 50% capacity, this has 1% capacity, this has 100, then it's going to go to 1 because that can handle the request better than the other ones that are already busy, that have a higher or lower bandwidth. And you can configure it as you need based on IP address. Say, hey, if they're actually going to this IP address, then they need to look at, again, think about all those servers. They want to get to the database server, or do they want to get to the web server? If it's based on the region or based on the content. Why do we need load balancing? It makes sure that, you know, your information, your transmission is reliable. You know that you're not going to get an error, that your system cannot handle it. It helps you to be able to be scalable. You can actually go from there, and it increases the performance of your system. So routers, again, we didn't talk about them. but they are very important within your network to make communication go through peacefully. So you could have, it takes information, it matches the IP address, because it would say, hey, this destination is this IP address, it transmits it to that particular IP address. It could also be a physical, where you have all these circuits in there, or you can have a table that you have actually set to have your packets being transmitted. Okay, so we talked about public network, how the VPN makes a network private by implementing that tunnel in there, and so on and so forth. We also talk about private public keys, excuse me, and SSH in a nutshell. So this is an example of an SSH command. We wouldn't go through this in detail, but it's just lines of code that you send, to be able to get directly to the kernel and then affect a particular system. So it's known as CLI, and what we usually use is GUI, okay? And if you don't have that SSH client, you can always use PuTTY. PuTTY is it's used through the internet to be able to access it. So when I said CLI and GLI, this is what I mean for, oopsie, no, where did it go? Okay, let's go this way. Okay, so we talked about hardware and software. In order for you to connect to your hardware and software, you can either use GUI, which is graphical user interface. This is what we are actually using, what you can see. Or you can see CLI, which is command line. So command line interface is what actually uses SSH, but it's all the same commands. When you click on a button, when you use your mouse, you're all sending all of this information is going to the kernel to affect your hardware. Sounds good? Everybody okay so far?
Yes.
So we've talked a lot about networks. I was hoping we didn't have to go into that much in depth, but there's a lot more about networks that we can talk about, but on another day. So I think at this juncture, you actually have an idea what networks are about. So let's jump back into our cloud, and then we talk about what cloud computing is all about. Sounds good? I keep going back. Every time I try to scroll, it takes me back. Okay, there it is. So yeah, we've been able to talk about network fundamentals. Let's talk about some principles of the cloud. Then we'll talk about cloud storage and design. So let's jump into that real quick. So again, what are some of the examples of cloud services? Microsoft, right? Back in the days, you need to buy a CD, install it on your machine, then you have Microsoft. If your friend wants the same Microsoft Office, Microsoft Word, and so on, they'll call you, beg for your CD, burn it, and so on, and then go and install it on their machine. That's how things used to work before. But now it has evolved so much so that if you need software, you just go online, okay? What do I mean by that? If you need to use Microsoft Office software, all I have to do is come in here and type office.com. If I go to office.com, it should take me directly to, all I need to do is log in. From here, I don't need to buy or anything. All I do is sign in. Once I sign in, I have access to all the products. I can have the apps and services that are available. There's Excel online, there's Word online. OneDrive is where you store your information and all this other software. Again, software is also known as apps or application, okay? So that's an example of Office online. Gmail, everybody has Gmail. That's an email service that's online. Before, we always have to have our email stored on your machine, but now it's stored online. Okay, when we had Outlook, you have to have it installed on your machine back in the days, but Gmail changed everything. Now our emails are being stored on Google server and giving us all that. The same with Netflix. Back in the days, if you needed to watch a movie, you have to go to the, what do you call it? So the movie, what do you call it? Rental agency to rent a CD, come home and watch it, and then go and return it, and so on and so forth. But Netflix decided to figure out a way, save all those movies on their servers, wherever the servers are located. Now, if you want to watch a movie, you just sign into your Netflix account, click on the movie, it shows on your TV or on your phone or any device you have. So those are all cloud services. Instead of having all these things stored on our own computers or our own servers, it's now stored on someone else's computer. And then we can use it based on the connection that we have established over the network, okay? Salesforce is another software that's being used for customer relationship management for these big companies, all right? So we've talked about how traditional computing worked. We've also talked about the importance and advantages of cloud computing. And then we talked about how things changed. You know, we didn't just jump from traditionally how it was done to how it's done now. You know, we actually had to go through virtualization, okay? Now that we've talked about those three, you know, traditional, which is also known as on-premises. On-premises means your servers are located on your premises. And then we had virtual, which is, again, having multiple operating systems on the same server or on the same computer. Now we want to talk about, what was I? The different types of models, okay? So service models per se, or should I say types, the different types of models that you have in cloud computing. So think about what we just talked about here. You having your hardware, your operating system, and your applications. How exactly will it work with the cloud? Okay, let me try to paint a better picture here. If we see the way things worked before. So let's go into the scenario where you have your data center, right, that you have built. So I know you asked earlier what the data centers are. You have all these servers. One server is for DNS, one server is for databases, another server is for firewall, and so on. All those different servers are located in one place. You've gone ahead and realized that you're not using it as much as you need to use it, which means you're wasting all your money and wasting your resources. Now you've tried using a virtual server to allocate it so that you can use one server to do 10 different things and so on and so forth based on the different virtual machines. It still didn't work out because your resources are not elastic. You cannot expand. You're going to have to buy. And even though you keep buying all this upfront costs, you also need somewhere to keep it. You need to pay your electricity and other things. So you figure the best way to improve is to get cloud computing. With cloud computing, you're sharing resources with other people, and then you're saving the cost. You're only paying for what you request, okay? So you're paying only as you demand it. You're not paying for extra stuff. If you need more capacity, you pay for more. If you need less, you pay for less, okay? So with that, you're able, actually, again, like I said, services are being built on demand, okay? By the hour or by the minute, depending on your cost. So it reduces that cost. You know, I know this is not an economics course, but if you think about it, if I had to build a company, like I said, I need capital expenditures. What is capital expenditure? It's your upfront cost, the upfront money that I have to put aside to buy all these things, you know, rent the space and so on and so forth. The operating cost is the money that you have to pay for it to continue working, like your maintenance, your monthly rent, you know, and so on and so forth, your electricity. So all of that is going to be turned into just your operating expenses. So your operating expenses is all you're going to worry about. Why is it good? Because there's high reliability, okay? High reliability and disaster recovery. You're sure that even anything happens, your data is going to be there. And if it's actually set up correctly, you will not even have any interruption. No, think about all these big companies. How many times are their services down? Rarely do you find the service down. And why is that? Because you have been able to put your stuff on the cloud. There's redundancy. The cloud companies have different regions. What do I mean by that? We talked about data centers and we clarified it. When you look at Azure, Azure is a Microsoft company. They have data centers in about 60 or more regions, probably a lot more right now, okay? So all of these are found in about 140 different companies. Those are places that they have, I don't know if I should say thousands or hundreds of thousands of servers that are in there that are providing services for everybody, okay? Your data is redundant in all of these servers. If somebody is in Japan, they need to get your data, they can easily get it because the data center is close by. If somebody is in Canada, they can easily get it because it's close by. If somebody is in Australia, they can easily get it if it's close by. If it's in Europe, there are multiple data centers in Europe. It makes your information very easy to get to. Okay, if it's deleted on one server, the other server has a backup that is replicated. So there's high reliability, high availability as well. Okay, that said, let's take a look at what happens on the left here. This is a traditional or on-premises setting, okay? You have your applications, your data, everything is working on your premises, on your servers. Your network is being set up, your storage, your servers, everything, operating system are all there. When you go to cloud computing, there are 3 different types of models, okay? Let me go back all the way to the beginning so that we can talk about this clearly. The 3 main types of models are known as infrastructure as a service, platform as a service, and software as a service, okay? Those are the 3 main models that you can have. What do I mean by that? With infrastructure as a service, what you're being provided is, think about that CPU. You're being provided with compute power. They'll give you above CPU or as much CPU as you need. And then think about storage. They'll give you a block of storage. You can store as much information as you need. They also give you a network because you can connect to all different areas in every different place that you are at. So they give you just their infrastructure. You're paying just for infrastructure if you're going to go with the infrastructure as a service model, okay? For platform as a service, what is a platform? Platform is something you can stand on, right? So an operating system is an example of a platform. You have an operating system, all your different software communicate with the operating system to get to your hardware. So platform as a service, they give you object storage. It gives you identity where people can actually check, log in and log out. It gives you runtime, you can run your applications, okay? So it's like having an operating system in every single one of these countries. It gives you a database and a queue, okay? Why do you need that? To be able to have less control and give more control to those guys to maintain all your stuff. The third one is software as a service. Software as a service, you have monitoring, content, collaboration, communication, and finance, all of that into it, okay? If you try to take a better look, to be able to see what areas you have control over and what areas you don't have control over. Let's take a look again. With on-premises, you manage everything. Everything in green here, you are the one managing it, okay? Nothing is being managed by your provider or your vendor. But when you have internet as a infrastructure rather, as a service, their vendor, the provider, is the one that's managing your network, your storage, your servers, and the virtualization. So you don't have to worry about your storage running out. The provider will make sure that if you're paying for that storage, that's it. They're just going to give you that storage as much as you need. Next is platform as a service. Now, the vendor also has to manage your operating system, middleware, runtime. This is important if You don't want to have to be updating, installing new versions, and so on and so forth. Your vendor does that for you automatically. You don't have to worry about it. Your things are going to be up to date, run as perfectly fine as you need. But then software as a service, they manage everything. All you got to do is just go ahead and log in and you're good to go. Okay, think about Gmail. We don't have anything. Everything is on their server. We just go in and run with it. Now, this might sound confusing. So let's take a real world example. Okay, think about pizza. If you want to make pizza, there are many ways you can, or if you want to eat pizza, there are many ways you can eat your pizza, right? If you create your own pizza at home, it's very similar to the traditional way of how you would have a server. All your stuff is being made at home on premises is the traditional way. But if you go and buy pizza that somebody else has already mixed, they have mixed everything, put it in the freezer, you go and buy it, bring it home, put it in your microwave or put it in your oven and bake the pizza, that will be infrastructure as a service. They have already mixed all the pizza for you, mix the dough, put the tomato sauce, put all the toppings, put your cheese on it. All you need is your fire. You put your fire in your oven or in the electric or gas cooker and you make it, that's it. That will be infrastructure as a service. But for platform as a service, they'll go a step further, okay? It's like somebody is going to deliver you pizza. You buy pizza, they bring it to your house and give you, because they are going to use all their, fire, oven, electricity, cook everything for you. All you need is your table to sit down and your water or your drink, and that's it. But when you talk of software as a service, that's when you actually go out and eat on their table, use their cutlery, drink their water or drink their drink, okay? That's when you think of how the different levels of control. You have all the control with traditional on premises, but with the different models, your control gets reduced. With software as a service, you have no control, you have nothing to manage. Does that sound good?
Yes, yes.
Makes sense, right?
Mhm.
Okay, so here are some examples, okay? The popular providers for infrastructure as a service. You have Microsoft has Azure, Amazon uses web services or AWS. Google has a compute engine or Google Cloud Platform, okay? Again, for platform as a service, Amazon has its Logic apps, Heroku, and so on. Oh, sorry, Microsoft has its Azure Logic apps, and Amazon has the Elastic Beanstalk. But software as a service, again, think about Microsoft Office. Everything is on the cloud. Google Suite, we are using Google quite a lot. Salesforce, the same. Dropbox, I don't know if anybody here has used Dropbox. All the stuff is managed by them. We just go in and use them. So again, what is infrastructure as a service? You use infrastructure as a service if you're going to have a test environment and you need high performance computing because your computer is slow, or your computer does not have a strong CPU, then you use their own CPU, use their compute power, use their storage. If you need to back up your data, use their storage, use their compute power, use their network to be able to get big analysis done, okay? For platform as a service, you want to develop, you want it for business intelligence, analytics, development framework, because that's what you're going to benefit from, okay? And for software as a service, again, help you to be mobile. You can work from anywhere. I don't need to have my computer with me. Everything I just take and save on Dropbox. I go anywhere, I can get to it. If I send you an email, I can also read that email wherever I'm located at, okay? So you have access to sophisticated applications when you use that. Does that make sense? Yes, no?
Yes, it does.
Awesome. Now let's conclude by talking about the deployment models, okay? You can deploy your cloud in many different ways. Okay, we've talked about, infrastructure as a service, platform as a service, and software as a service. Actually, there's a lot more which I didn't want to talk about, but let me just mention them in here because it's worth mentioning, because there are many different types of services that you might need in future. So apart from those three that we've talked about, you also have business processes as a service. Everything on the cloud is being given to you as a service. You're just renting it, okay, rather than you having to pay for your own and build your own yourself. You have communications as a service. If you are into machine learning, there's also machine learning as a service, database as a service, and functions as a service. Those are all provided to you as a service, okay? Now, the three different types of clouds, let me write that down because I believe if I write it, you guys will remember it more. Come on. Never mind, I should just put something here. Okay, so the three different types of clouds that we're going to talk about are the public cloud. Of course, I can't type. The private cloud, and also the hybrid cloud. There's a fourth one, which is a community cloud. I think it's also worth mentioning in the hybrid cloud. So what are these different types of cloud? The public cloud, here again, whatever you want to do, you can get it, okay? If you need more resources, you get it. It operates with third party. Again, client just pays what they get. Think about what we have in this case of Google Cloud Platform, Amazon Web Services. That's the entire public has access to it, okay? Private cloud, that is for when you want to lock things down in your company, okay? You purchase the software, you set it, you set your own individually within your company, only your network. It has limited scalability and you control your own security. So if you have a company that you don't want to be sharing your resources, you don't want your information to be next to somebody else's information on the server, then you get all this virtualization software and install it or get it configured within your own networks. You take care of your security, you take care of your scalability and so on. Now, if you want to combine two of them, maybe you still want some other stuff that is not very sensitive to be on the public cloud, fine. You can still have your stuff on the public cloud, and then you want some stuff that is very sensitive to remain within your private cloud, then fine, you can have both your public and private cloud, okay? So it depends how you want to set it up. And then the third one is a community cloud. So think about organizations of common interest. Okay, let's say all schools decide to be sharing some reports, then they can have a community cloud where they're going to have all the information from all those schools set and shared in there. So the clients know who the other clients are, and there's less scalability and flexibility as well. Does that make sense?
Just have a question.
Yes.
For this hybrid cloud, you say it combines both public and private cloud. Does it mean, like, I don't really understand, because
Okay.
for public cloud is open to the public and they have all access to get what they want. But with the private cloud now, if it's a company, they limit the information they give out, or they don't publish everything. So how do they combine now both?
Okay, so let's take an example of, let's say, a hospital, right? The hospital wants people to go to their website, right? And the website has information that they want to know, like, hey, they want everybody to know the doctors that are at the hospital, the nurses, the pictures of the hospital, the instruments that they have, all of that, they put it on their website. They decide that they want that website to be hosted on the cloud. This time, there's nothing sensitive in there. They go ahead and put it on Azure, Microsoft Azure Cloud. Everything works just fine. But now they have to save patient information. That patient information, they want it to be more secure. So they create their own private cloud. They purchase all these virtualization software, put all the information in there. They build their own cloud within their own security. Okay, they control it within their own network. They have their firewalls, their load balancers, all those stuff around there to make sure that nothing gets inside their network. In there, they can store their patient information, their patient history, and so on and so forth. So they're actually using that public cloud and also using the private cloud. And then it becomes now a hybrid cloud because they're combining your public and private together. Does that make sense?
All right. Yes. Understood.
Yeah, so that's just an example for hospital. Maybe there's also financial institutions. They don't want their financial stuff to be out there. And many other companies, for whatever reason, they might have private information that they probably don't trust that public cloud, because if something breaks in there, everybody will find out their information and they'll be in trouble. And not only that, sometimes banks, financial institutions, or medical institutions, they have certain rules that they have to meet. If not, they're going to be facing some tough questions from the government. So government and other rules or regulations are set in place.
What just happened with the server?
Exactly. So you have all those things set in place because they'll have to do auditing, they have to do their due diligence, compliance. You have to be able to comply, otherwise your company is going to be in serious problems. Okay. Sounds good? All right.
Yes.
That's it about the different types, public, private, hybrid, as well as community cloud. So there are different types of characteristics that we definitely need for cloud computing. We've talked about some of them already, but again, elasticity, it can grow and shrink depending on how you need it. You have a lot of resources, okay? A resource is divided amongst clients as they need. You're not the only one that's using the server, others are also using it, okay? And there's rapid elasticity, there's fast allocation of resources, and so on and so forth. Again, it's self-service. You automatically access it at any time, whenever you need it. You don't have to wait for somebody to wake up or someone to get back to you. You have access to your stuff as you need it. It's also scalable. You can increase it or reduce it, the size or the capacity based on how you want it. Again, the network access is very broad all across the world. Okay, it's not just local. For instance, if you have a network in your company, only at your company you can access it. But with the cloud computing, it can be accessed anywhere. You only pay for what you use, so it's pay as you go. The availability is very high as well. So those are the main things. All right. Now we talked about the control and management. You as a customer, you also have some things that you're responsible for in the cloud. The provider also has its own things that they are responsible for. So just because you're using a cloud doesn't mean all the information, everything is their responsibility. You also have your own responsibilities. Okay. So for instance, customer is responsible for the data. You cannot come and complain to the cloud guy that the data is not clean, there is no input. You're the one that input the data, you're the one using it, so it's your responsibility. All right. You're also responsible for the applications platform, those that are, you have to create an identity, people that are logging in and out and so on. So you have to manage your access, identity, and so on. They are not going to do that for you. All right. So network traffic, file system, encryption, integrity, all that data integrity stuff, it's your responsibility. All right. Also, your network, firewall configuration, and operating systems, you have to make sure you set it up. They can help you to do it. They have tutorials and resources to help you, but you have to do it yourself for various reasons. But what then are they responsible for? They are responsible for the computation power. They're responsible for giving you that CPU. Instead of you using your CPU, which might be limited, they'll give you unlimited CPU. They give you storage. They give you database. They give you the network, because they are all up around the world. So those are some of the things that they give you. They have these many regions. They have availability zones and edge locations that you can utilize. Everything that is stored on this server is replicated on all the servers. Okay. Does that make sense? Everybody good with that?
Yes.
Yeah, so again, in a nutshell, that's exactly what you get in terms of characteristics and some of the things you get from cloud computing. All right, what questions we have? I know we've taken about 30 minutes to talk about cloud principles, and we took another 30 minutes to talk about network fundamentals. So we've already gone for over an hour now, and we still have to talk about cloud storage, cloud design. And for those, let me just take a quick discussion on that. So cloud storage, again, think about, let's say Dropbox, right? Cloud storage has to do with you having, let's see, how do I put it? Saving all your files, for instance, your files, be it a text file, a Word document, a PowerPoint, all of that being saved. So there are many different cloud storages that are being used. Some examples would be OneDrive. Does anybody here use OneDrive?
Yeah, something like that. Yeah.
OneDrive is a Microsoft product.
Microsoft, yes.
Yes, you also have Drive, Google Drive, which is obviously a Google product. So when you go to Google Drive, you should be able to see a bunch of tools. So let's see if I go to, okay, this is Microsoft Office. On Microsoft Office, there's OneDrive that is strictly for storage of your files, be it a picture, file, text file, and so on and so forth. Just like Dropbox. Dropbox is also an example of software that does that. Another is Google Drive, which we just talked about. So those are some examples that you have for cloud storage. So what exactly are you storing? You can be storing an object, or you can be storing just a file, right? And there are certain features that you have to use to be able to talk about that. Now, there's something known as content delivery networks, CDN. So content delivery networks is very similar to data centers. When you decide, for instance, that you want to store your content, in this case, let's see, I should make a quick search here, CDN for Amazon. Let's see, map. Okay, so here's an example of the CDNs, which is a global content delivery network that you have for Amazon. Oops, I clicked on it instead. It's going to take me to that. For Amazon Web Services, okay. I should open it in a new tab. There you go, that's better. Okay, so it gives you an example of all the different locations. So for instance, you see you have different areas, you could be storing them in edge locations or also storing them in a main region, as you see. So this is a regional, and you can see the purple one is showing you edge locations. I mean, there's more than one edge location in this, probably because it's Texas. And nope. And so on and so forth. Again, Australia has another one, and so on and so forth, all over the world. So if you have a website, and let's say I located somewhere here, I have my physical server and I save all my files on the website. If someone in Cameroon is trying to get to that website, the number of connections that they will have to go through to connect to get to that website might slow down my website a lot. But if I decide to put my website files on the cloud, on the CDN, right, on the content delivery network, it gets replicated all around, so that if somebody is in Cameroon, they want to get to my website, they'll get to the shortest distance, and that's it. They don't have to connect to multiple areas before they get to it. If someone is in Japan, they need to get to my website, it's being replicated here, they can easily get to it. There's low latency. So that's the main thing that you're talking about when you talk about this, okay? So there's very low latency with your stuff because data can be easily accessed wherever people are located. Does that make sense?
Yes, sir.
Awesome, awesome. Now let's talk about, where is it? Right here. So again, it's the same thing, not just websites, the same with the OneDrive. If I need to get my files, I can easily get them anywhere. If I want to share something with you, I can save it on Google Drive. Everything you see in here in our notes on Google Cloud, they are all shared through Google OneDrive. Let's see. So this is an example of Google Drive. If you click on here, you can easily get access to it. That's because it's using cloud storage. With that cloud storage, you're able to have access to all of this content that is being stored using OneDrive. Sounds good? So finally, we've talked about this before, the cloud design.
Excuse me, sir.
Yes.
Is it possible for the data to get lost?
Very good question, which actually takes us directly to what we're about to talk about. Cloud design. Is it possible for the data to get lost? Very, very unlikely, because there is redundancy. Okay, so when you're designing your cloud, the principles of cloud design, the first thing you want to do is you want to make sure there's redundancy. What is redundancy? Redundancy is usually not a good thing in life. Most people don't like it. You don't want people asking you the same question over and over, or you repeating yourself. But in this case, redundancy is a good thing, because every single file that is located here in this data center is also located in this data center. So there's replication across the board. So if everything gets deleted from here, well, at the end of the day, they probably have automatic backups and synchronization, right? Some of these storage networks, they provide you synchronization. So if you look at your, what do you call it? At your desktop, okay, you have, okay, Apple also has iCloud. I forgot to mention about that. Apple has iCloud, and everything that you have on your iCloud, it cannot be lost, because if it's lost, you can always recover it, okay? So that's why there is high redundancy plans and high availability. It's available to you everywhere, anywhere you are at any time. There's also disaster recovery. If, for instance, oops, let me go back to it. If, for instance, there is an earthquake in the eastern part of, or should I say western part of the USA, and some horrible, impossible thing happen, and this part gets chopped off and goes into the water, all these data centers are lost. It's not going to be a big deal in terms of your data, because your data is still located in all these other ones. So that's what is known as disaster recovery. Now that there's a hurricane and there's a tsunami or whatever going on in Florida, because all these data centers are down, there's no power, there's no electricity, there's flood, the machines have all gotten wet and fried, you still be able to perform business, because there are still data centers all around here that can be used. So when you're going to build a cloud network, a cloud computing infrastructure, you have to make sure that there's redundancy in place. And how do you set that up? Maybe it's just by simply having backup plans. You have synchronization that takes place. If my computer gets missing today, or I lose my phone for one reason or another, I should still be able to have all my data. All I need to do is just come in, sign in. Once I sign into my network, I should be able to come back in here and have access to all my classes that I've been teaching. So the main thing here is redundancy being in place, high availability, and the disaster recovery. And you just need to make sure you set up recovery point and time objectives. So you might want to say, at this particular time, I need to be able to synchronize or back up all my data, and so on and so forth. Does that make sense?
Yes.
All right.
This means that when you're having many data centers, this means that you can, redundancy is good, because when you're having many replication of those data centers, you can easily have access to those information, those same information.
Exactly, exactly. You have access to all that information. And again, this is an example for, let's see, this is a CDN for Amazon Web Services. Let's check out the CDN for Microsoft. And you see it's very similar to that, okay? Let's see. I want the one that actually has Microsoft in there, because sometimes, oh, come on. Let's see, Microsoft CDN. Maps, let's go to, okay, there you go. It was actually the very first button. So on here, they will usually start by showing their maps. Where is it? I don't think they have a map in here. Why is that? Or is it because it's still loading? Come on. Where's locations? There you go. All right, so instead they have a list. They don't have a, that sucks. They don't have a map. I thought they had a map. Okay, I need a map. Let's see. There you go. Okay, so that's a map for Microsoft. Next, I need a Google GCP map. Google Cloud Services. So as you can see, never mind, they actually have an interactive map that's put together. So somebody went ahead and took a list of all those places and created a map. So you can see these are all the areas. Unfortunately, there isn't one in Africa, you know, but there's some in Australia. You can see in China, all these areas, South America, North America, there's none in Canada as well. But let's check out Google. And this is what Google's map looks like. So Google Cloud, these are the different locations that you have currently with 3 zones and future with 3 zones. So they're going to have more in here in Doha and so on, another one in Berlin. But you can see the areas that are concentrated. So again, cloud is very, very new. Obviously, they're going to focus on the US and Europe. Eventually, they're going to reach into Africa, but by that time, you already have an idea what cloud computing is, what cloud networks are. You know, with that, if you start learning about Azure, you know, which is going to get you into more details, or learning about AWS, or learning about Google Cloud, then you find yourself in a good place before others start catching on to that. Okay. So with that, there is that redundancy that we've talked about, high availability and disaster recovery. If there's a disaster in one area of the world, you can actually, you know, use the data centers from the other areas of the world. Okay. So there's a lot more we can talk about with cloud computing. You know, there are also a lot of products, solutions, pricing. You know, each one of these you can go into the console. As you can see here, I'm logged in as in my Google account. I can click on the console. I haven't used this before, but while I'm clicking on that, we can also use Amazon. Let me go create an Amazon or sign in. Let's see, I'm not sure if I have an Amazon account yet. So here is exactly what you need to do in order to get a AWS account. So you can create an account, use a identity and access management user, IAM user, and so on and so forth. The same with Azure. All you have to do is come into Azure sign in, Azure portal, with your Microsoft login, you're able to go in and you should be just fine. From there, you can create, let's see, here I can create a VPN network or VPC network. I can get Compute Engine. can check my billing, cloud storage, and so on and so forth. There are a bunch of products that you can use. Just like that, as you can see, I'm connected to Google Cloud. That's my login, and I can search for resources. What do I need? Do I need networking resources? Do I need databases? Do I need storage? Do I need compute power? Do I need continuous integration and continuous development with artificial intelligence? They are all in there. I did not have to have that upfront money saved to be able to go and start building my own server. If I need a database, I go in here and click on databases and tell them, hey, I need a database of this size, and so on and so forth. What kind of database do I need? Do I need a SQL database? Okay, yeah, I can go in there and then click on SQL. Takes me to another page. From here, I can start building my SQL database. All I have to do now is make sure I pay my bill when the time comes. Otherwise, they're just going to lock up my data. So obviously, I know I'm going to need this data all the time. So I need to be paying for it. So I can create an instance of the SQL database and start working from there. The same with Google, or sorry, with what do you call it? Microsoft. I can sign in, I can use GitHub. We haven't talked about that. We'll talk about it next weekend. And Amazon, okay? So it's as easy as that. Those are the three big players when it comes to Google, when it comes to cloud providers. There's AWS, which is Amazon. There's Alibaba, which is also a cloud service. There's Google. It used to be called GCP, Google Cloud Platform. Now it's just Google Cloud. IBM also has its cloud. There are many different types of clouds as well. Microsoft and so on. So you can check out any of these links, create an account in there if you need to, play around with it. If you have a website, you can go and save your website and have it on there, manage it as you need. Does that make sense?
Yes.
Awesome, awesome. What questions do we have? What questions do we have? I know we're almost at the end.
Let me ask a question. It might be funny, but I'm a profane. So when we have to do it here, I spend quite pretty sum of money on VPNs.
Yeah.
And I went on, one day I was browsing on YouTube and I saw the create your VPN, learn to create your VPN on your own. Yeah, but so can you create a VPN on your own without actually being part of those cloud providers, service providers? And
Okay.
if so, how easy is that? How possible is that?
Okay, very, very, very good question. To answer it effectively, let's go back again to the definition of VPN. What exactly is a VPN? Again, VPN stands for Virtual Private Network, okay? So it's like a tunnel, it's a tunnel that has been created that makes sure that your data is secure. So one thing with computer science and IT is it's always good to leverage what others have already created and they have tested and it works perfectly fine. Because if you try to create one yourself, I'm not sure, what the way it was presented, but if you try to create one, obviously you have to be able to understand the, ins and outs of a network, right? And then you want to make sure that you do it in entirety. What I mean is you have to plan. What exactly is it that you'll be transferring? You have to have all those resources in place. Once you have built it, you have to be able to test it, right? Once you test it, you have to be able to keep the maintenance. So will you have the manpower or the resources to be able to go through the entire process of creating it, testing it, maintaining it, and then updating it each time, because the VPNs that are already popular, that are known, that are being used out there, are ones that are supported very highly. Okay. So for instance, if you want to get into the VPN business, let me say, if you go in and search for VPN clients per se, you see quite a good number of them. It's up to you now to see which one is going to work for me. Okay. Because the VPN client is going to be a software, okay, software technology that gives you that security between a user and a VPN server. Just like a company is going to tell you, you need to install this VPN software. They'll have to go out there and check out vendors. They'll check the vendors and say, okay, this guy provides this, provides that, and so on. But how does VPN work? You have to be able to understand that. I know we skipped that part in our class because it's more detailed, but VPN pretty much is you have to have a private key and a public key, okay? So again, if you understand the concept of that private and public key, what makes it private, what makes it public? You need to have a hash, okay? The hash needs to be able to how do I put it? Once you send in your information, everybody knows your public key. So everybody can confirm that you're the one sending the information, but only you alone has your private key. So if I'm sending something to you, it can only be opened by your private key. Beatrice will not be able to open it because she doesn't have your private key, but she will know that I am the one that sends it because it has my public key. So I'm sending stuff with my public key. You see that, and you know I'm the one that's sending it, and vice versa. So it's a whole, for you to be able to create yours, you have to really know very much about networking and be able to make sure that someone or some group doesn't know more, that they'll be able to break into it. Because if you create your own VPN, we talked about this when we talked about cybersecurity. There are different threat levels or different threat actors. There might be a bunch of guys in Russia that are sitting there and just working on breaking code and so on and so forth. It might take 2 or 3 minutes to be able to break your VPN and it's no longer secure. But you want to be able to use one that is well known. People make sure that it's being updated every time, it has never been broken, and so on and so forth. Does that make sense?
Yeah, I understand.
Awesome. But yeah, you can always, they can probably have let's say a pipeline that you can use to be able to make everything. But for you to be on the safe side, again, everybody can make their own car or make their own computer, but how far are you sure that it's going to live up to expectations to other persons? I can make my wire motor and drive peacefully, but without being able to upgrade the next time to metal or to something else, then I'm going to fall behind.
Exactly. When did my son leave?
I think
when did Junior leave?
I think he just left.
I just discovered that we are just 3 of us now.
Yeah. I just realized that too. Okay, it's almost 2 o'clock here, which means it's almost 7 o'clock in Cameroon. So I'm going to let you guys go. If you have any more questions, reach out to me, and then I'm going to update everybody.
It's almost 2 a.m. It's almost 2 a.m. here.
I see. Well, I hope you guys have a wonderful weekend. Next week, we're going to talk about software programming. Sounds good?
Okay. Yeah.
You are welcome.
Thank you very much.
You're welcome. Enjoy your weekend.
Same here.
Thank you. Thank you very much.
Bye-bye.
Bye.